Hey guys, this will be our last video for this chapter. This is going to be over congruence and overlapping triangles. Basically what we're going to do this time is we're going to figure out how to prove certain parts are congruent, but our triangles, instead of just being connected to each other, they're now going to be overlapping. So they're not just going to, they're not always going to just share a side or create vertical angles. Now they could potentially have a pair of angles that are congruent because they are in common with each other. That's where they're overlapping. So there's no theorems or anything that you need to know for this section. I'm going to give you a couple examples so you have them to have in your notes. Remember that you need to have these all filled out for class tomorrow. So make sure that you write whatever we do on the video down and come prepared for review in class. First example is a picture of two triangles that are overlapping. And the question says, what common angle do triangle ACD and triangle ECB share? What can be helpful is if you figure out what are the parts that they have in common, or like for example, what two segments are shared by the two triangles. If you look on here, the BC and CD are shared by both triangles. And what happens is they end up creating angle ACE, or you could even just call it angle C. And that would be the answer to this question. That is the angle that the two triangles share. Second example we're going to do is a proof. This time we're going to prove that two corresponding parts of the two triangles are congruent. And so based on what we have here, we're given that angle ZXW is congruent to angle YWX. Angle ZWX is congruent to angle YXW. When they give you a picture and given information, always take the time to mark them if they're already not marked. So the way that you could actually do this, ZXW, you could mark that with 1, YWX and 1. And then for ZWX and YXW, you could do like this. That could work pretty nicely for this. So now that you have those marked, you then need to figure out which parts of the two triangles do they have in common. They're overlapping. So we got to figure out which two parts are in common between the two. And if you look, that bottom side is what's in common. So they share two angles and they share a side. Now, since they're overlapping triangles, we can then determine, is this maybe, are they congruent by angle side angle? Are they congruent by angle side? We know there's two angles in one side, so those are our two options. If you're a visual person, a lot of times drawing the two triangles separately can be helpful. So ZWX and YXW. We know that these angles are congruent to each other, and then we know that these angles are congruent to each other. We also know that WX was congruent to XW. So if we look at this, this ends up being in the order of angle, side, angle. Angle, side, angle. So when we prove that these two triangles are congruent by angle, side, angle, we can then say that all the corresponding sides are congruent and corresponding angles are congruent, which can then help us prove that ZW is congruent to YX. So this proof is going to be just like the ones that we did in 4-4 when we talked about CPCTC. So I'm going to pause my video and I'm going to write out the proof real quick, and then I'll come back and show you the answer. Okay, so the proof, angle ZXW is congruent to angle YWX, because that's given to us. WX is congruent to XW by the reflexive property of congruence. Angle ZWX is congruent to angle YXW, and that was given to us. So then we know that triangle ZWX is congruent to triangle YXW by angle side angle, which then we can conclude that ZW is congruent to YX because of CPCTC. For this problem, I want you to log on to Pearson, and you can do this after the last example, which is next. When you go on to Pearson, click Programs, go to Unit 1, Topic 4, Lesson 4-7, and I want you to look at Example 3, which is the using two pairs of triangles, and watch that video and go through the proof and write that proof down in your notes. Here's an example of a proof being done for an example of several triangles that are overlapping. When you have a question like this, you have to figure out what's important and what's not. A lot of times you'll have to prove one pair of triangles congruent and then prove another pair of triangles are congruent in order to prove what they're asking you to prove. In this case, since you're trying to show that BX is congruent to DX, you want to show that triangle BAE is congruent to triangle DEA. That will help you have enough information to show that triangle BXA is congruent to triangle DXE, which then in turn would give you enough information to show that BX is congruent to DX. So it'll be a process that you have to go through. By knowing what kind of triangle CAE is can be helpful as well. In this case, because we know that CA is congruent to CE, that means that CAE, triangle CAE, is isosceles. So in this case, if you follow along with the proof with me, we know that BA is congruent to DE, and that's given. That doesn't tell us anything else, so we'll move on to the next given. CA is congruent to CE. That tells us that that angle CAE is congruent to angle CEA. And we know that because the base angles of an isosceles triangle are congruent. You could have also said the isosceles triangle theorem. That would have worked as well. We also know that AE is congruent to AE based on the reflexive property of congruence. What happens here is by telling that information, we have actually proven that triangle BAE is congruent to triangle DEA by side angle side. BAE and DAE are drawn separately on your screen right here. We have proven that BA is congruent to DE. We have proven that CA is congruent to CE, which tells us that these two angles are congruent. And then we've proven that these two sides are congruent. And so that would be side angle side. Now, with that, we can now say that ABE is congruent to EDA, which I'm going to go ahead and do on this picture on the right side. Those are congruent by CPCTC. And then we know that just by definition of vertical angles, these two angles are congruent. And we also know from earlier that BA is congruent to DE. And so angle side will help us with that. Well then, since triangle ABX is congruent to triangle ADX, BX is congruent to DX by CPCTC. So notice here that we had to do multiple things in order to show that BX was congruent to DX. We had to start out by showing that these two triangles were congruent, which then we were able to use CPCTC to do this statement, because that statement is what allowed us to do angle side for these pairs of triangles, and then finish off the proof. So this is the longest proof that you'll probably see in this chapter. Overlapping triangles can get a little challenging just because of the overlapping part. So it's always very helpful if you just redraw all the triangles separately, because it'll help you see what's really going on. Separate it, and it makes it more visually appealing and easily readable. It's easier to understand what's going on. If you have any questions, you can come see me in the morning or during lunch. I'll be available. And make sure you bring notes to class, because we'll be having a question and I'll be checking over them, and start preparing for your test.